Very good. So is there any other questions, or we'll just skip or go ahead to the next thing? So I'll just introduce this part, and then I think we need a 5-minute break, right, Bill? Because yeah, and then we'll go through the lab experiments, and maybe we even can get started on. We'll see how far we go. But the topic of this part is to cover the conventional PVT experiments. So that's the CC experiment, CVD experiment, DLE, and the different separator experiments. We'll also talk about uncertainties and QC methods associated with both of those. So CCE is what's also called, or we can get back to that actually here. Yeah. So this is just and in this part we'll not cover like sophisticated experiments such as gas EOR experiments. That's going to be a topic for Friday. I'm pretty sure. But we'll focus on these PVT experiments that you find in every single PVT report, and that you also find in the PVT reports provided as a part of the digital material. This slide is a slide that we like because it summarizes all the types of PVT laboratory tests, in at least from a high-level perspective. And the compositional measurements, which will be the topic of the next presentation. There we have, in general, two options: as the GC and also true boiling point distillation data. We'll talk about that later. For the standard PVT experiments, we have the so-called CCE experiments. So that's constant composition expansion, or also called CME, so constant mass expansion. So mass and composition. Then we have, for all practical purposes, two different depletion tests, the DLE experiment and the CVD experiment. We have a multi-stage separator test, viscosity experiment, and then this is stuff I will cover on. This is on Friday. We have different ways of measuring the so-called MMP, so minimum miscibility pressure. This is next presentation. And just what we like to do when we do this class is just to look at this and, okay, what is the key thing that each of these things is actually measuring? Each of these key measurements from a high. And the GC is, as we talked about, at least when we talk about measuring oils, we're measuring the weight percent of each component. The nice thing about the true boiling point distillation experiment is that in addition to the weight, we also measure the densities of each carbon number or boiling point cut, and also the molecular weight. And when we have the molecular weight and the weight fraction of each component, we can convert to moles. So that has a lot of the information that we like. The CC experiment or the CME experiment is the experiment that gives a lot of different properties, but the most important ones that you typically hear about a lot in this course, and when you talk about fields, is the saturation pressure. So that's both dew points and saturation pressure and type. So that's either a dew point or a bubble point. In addition to this, we're measuring also other properties, but we'll cover those other properties later. There's also a difference between legacy PVT cells and new PVT cells. So in new PVT cells, you can actually get the liquid relative volume, but the depletion tests right here give you either the VRO curve. So that will either be a shrinkage curve for an oil or a dropout curve for a gas condensate, and that's actually something for newer CC data that we see in these visual cells. You also get that data there. very important for tuning. And I think worth mentioning, at least between CC and the depletion test, is that the depletion test is also providing, or there's a compositional change going on in the cell, which is it's also good for tuning purposes, which is not the case for CC as it's constant composition. The multi-stage separated test, that's what gives us the information volume factors of the BO and RS. That's the BO and RS we used, for instance, yesterday when we talked about the oil in place numbers. The viscosity experiment, maybe we can guess what it measures, but it's the viscosity of oil, and that's an important distinction that I think I've heard about one guy that's ever heard, like Rosbone, I think, mentioned that he's seen a gas viscosity experiment done in the 80s one time. So for every single case, I think in the industry, the viscosity experiment is done for oil, while the viscosity numbers provided is always calculated, typically from League on Solids or something.
Yeah, we recently worked on a PVT project where the fluid system was highly near critical gas condensate with a liquid dropout of about 60%.
Yeah.
And there we had these measurements of the gas viscosity, single phase gas viscosities,
okay,
with this EMV tool. So,
okay. And that was
okay.
Okay.
But the magnitude is usually very small, and you should expect more error with those measurements.
Okay. So we have even seen it here recently.
Yeah.
So, but mainly oil. And we'll get back to a few things on that. This we'll save for Friday in detail, but for those of you who have talked or know about the gas COR and MMP, so minimum miscibility pressure, is something that's mentioned there a lot. I can just mention real quick here that the slim tube experiment gives us the true multi-contact MMP, so MMP by multi-contact. The swell test gives us the MMP by first contact, and the multi-contact vaporization experiment can be done backwards and forwards, and that tries to quantify or gives us data to be able to capture with the thermodynamic model, I guess, the vaporization efficiency or whatever we like to call that. But that requires the fluids to be two-phase because you like to measure vaporization. Very good. So on that note, Bilal, I'll just hand this over to you.